Alright everybody, welcome back to video 2 for section 10.1, defining convergent and divergent infinite series. In this video we're going to handle how to find partial sums on a graphing calculator to help us along the way in our estimation process. I'm going to show you, I'm kind of old school, I'm going to show you how to do this on a TI-89 model series and also on the old school TI-83 Plus. If you have a different kind of calculator, let me know. I can show you if you can't figure it out yourself. All right, so on the TI-89 models, what we're going to do is we're going to go to the catalog in order to pull up our command. And so let me clear out this stuff from the last video. And I'm going to go to my catalog, which you see right up here, the catalog key. And if I start at the A's, notice I'm already at the sum because I was using this. If you start at the A's and just kind of scroll up from there, you should eventually find the summation. And if you look at what it says here, it says 4 things that have to go into this summation: the expression, the variable, the low, and the high. So if I want to find, in this video we're finding the sum from 1 to 10 of 2n minus 5. If I want to find that summation on my calculator, I'm going to go ahead and pull that sum command out to the main screen, and I can type in 2n minus 5. And then I need my variable, which I used n. And you can use any variable. You could just go ahead and use x if you wanted to. And type in my lower boundary and my upper boundary. And if I hit enter, it's going to go ahead and find the sum of that series, just like you see in that window right there. If you're using a TI-83 style model, all right, looks like I was doing this looks like I did this on my computer as I was writing this lesson. So what we're going to do is we're going to press second and stat in order to go to the list menu. Okay, and once we're at the list menu, we're going to arrow over to math, and we're going to pull the sum command out of there by using number 5. That'll bring the sum command out to the main screen. Then we're going to go ahead and hit second stat again, and this time we're going to arrow over to ops, and we're going to pull out the sequence command, which is number 5. And then we want to type in, again, the same 4 things that we did on the 89. We want to type in 2x minus 5, the argument of the summation, the variable, the lower limit of the summation, and the upper limit of the summation. And I hit enter, and boom, tells me that the sum of those is 60. So that's 2 different ways depending on your calculator model. Like I said, if you have a newer like 84 plus model, there's a different way to do that. I would show that to you, except I don't have access to one of those on my computer because, I don't know, I'm stuck in the 2010s instead of the 2020s. All right, let's go ahead and we'll look at example 3 here. We're going to find the partial sum, S sub n, of the series below for n equals 150 and n equals 500. Do that using our calculator. I'm going to go ahead and use my 89 to do this. So I'm going to go to my catalog, pull out the summation command, and now I'm going to type in my argument, 8 divided by, I'll just use x times the quantity x plus 3, and I'm going to find the summation in terms of x, starting at 1, and here we want to find the partial sum for the first 150 terms, so we'll type 150 in here, and hit enter, and see how this does. Ooh, gave me a fraction. I'm going to tell you what, I do not want to work with this fraction, 6,368,000, etc. So I'll hit the approximate key and get a decimal value. And so this is telling me that the 150th partial sum is approximately 4.836. So this is a tool that we can use if we're unsure, if we're having trouble deciding if the partial sum leads to a limit or not. This is something that we can do to help us make that determination. I'm going to do the same thing this time with 500 terms, and we get this value. what do we get with 500 terms? It's going to take the calculator a little longer with 500 terms than it did with 150. And we get approximately 4.873. But we can kind of see that this sum is slowing down. And so hopefully we can find a value that it's going to converge to. I want to go back for a second to what we talked about in the last video. The very last example we were talking about, we said, hey, it looks like this is getting closer and closer to a value. And also here in this one, we were saying, hey, it looks like this grows indefinitely. What I could do is I could use my calculator as a tool here to kind of help convince myself. If I pull the summation out to the main screen, this first one is the quantity 4/3 raised to the x minus 1 power with respect to x, starting at 1. So let's say I put 200 terms in there. I'm going to go ahead and put 200 as my upper boundary, and that all adds up to, let's see what it adds up to here with 200 terms. Remember, we did it with 5, and we were kind of saying, hey, it looks like this continues to grow. Notice that if we do 200, we've got 2.9 times 10 to the 25th power. So that is going to keep growing, and it's obvious that that's going to diverge to us. Let's look at the last one here. We'll go ahead and pull our summation from the menu, and we've got, let's see, 1 over the quantity -2 raised to the n minus 1 power. And let's add that up from 1 to, let's do 200 terms. Find the 200th partial sum. And we'll let our calculator chomp away at this and see what happens. So let's see. I feel like I constantly need to have like Tom Petty's "The Waiting is the Hardest Part" on the background here. But it looks like that looks pretty convincing as 0.6 repeating, which we were already getting pretty close after 4 or 5 partial sums. You know, on the 4th or 5th partial sum. Let's see how close we would have been. Let's use a smaller number of terms. Let's go ahead and do 50. And see how it does with 50. See that? We already were, narrowing in on that value at the 50th partial sum where, we didn't get any more significant information from those next 150 terms, which kind of makes sense if you think about it. All right. That takes us to the end of this video. You're now at the point where you should be working on some practice problems. And so go ahead and work on some practice problems, and we'll see you next time when we talk about section 10.2. And we're going to start learning how to figure out when some particular series converge and diverge. All right, see you next time, everybody. Have a great rest of your day. Bye-bye.